To the third video in transformations. This one is going to be covering rotations. So far, we've done translations, which are slides, and we've done reflections, which are flips. Rotation is one where the word is pretty obvious what it means, but you can also, instead of rotating, you can use the word turning. We are going to be doing a lot of turning and spinning, and we're going to use terms like clockwise and counterclockwise to cover this topic. But I will tell you, of the topics that we cover, this is the one that you probably see the most out in the real world. As a quick reminder of the vocabulary that we've talked about a lot in this unit so far, pre-image is the shape that you start with or are given. The image is the shape that you end with after the transformations. So far, everything that the image and pre-image must be congruent. That is true once again for all rotations. The image and pre-image must be congruent. For our next topic, dilations, is where the shapes will be similar, or one shape will be slightly larger or smaller than the other shape. So a rotation, I like to think of it as like a Ferris wheel. So the idea is that you have a point of rotation right here, and you are rotating about that point in each direction, either counterclockwise or clockwise. And a lot of people are going to get clockwise and counterclockwise mixed up. My hint on this one is pretty straightforward. Look at a clock, okay? And think about where the 12 sign, or the 12 number is, and the second sign rotates around this direction, making that our clockwise. Counterclockwise is just opposite. So if you have the 12 and you're rotating the opposite direction, would make this counterclockwise. The most important thing when you're doing rotations is we're talking about the distance away from the center a lot. You notice that if I look at this cart right up here, is a certain distance away from the center. If I do my rotation correctly, if I pick any other point, the distance away from the center is going to be the same. Now, it's going to look a little different because you notice here we go up a lot and then over a little bit, whereas this one we go over a lot and then up a little bit back to the center. There's still the same pure distance away from the center. So remember that as you're working with these problems, the distance away from the center, or where you're rotating, cannot change. And when we talk about degrees, each individual turn we think of as 90 degrees because a full circle should be 180 degrees. So a turn from here to here is a 90-degree turn clockwise. A turn from here all the way down would be 180 degrees counterclockwise. But you'll notice that a clockwise and a counterclockwise rotation of 180 degrees are the same. So each individual turn we think of as a 90-degree turn in that direction. The full circle is 360. So if they ever ask you for a 360-degree rotation, you should end up back where you started. Now, I will tell you, I talk a lot about, you learn by challenging yourself and you learn by doing things that are difficult for you. This is my toughest skill. This is something that is very difficult for me to do naturally. So in this video, there's very possibly going to be small mistakes. If you find strategies that are better than my strategies, please, please, please show me, bring them to me, and we will work through them together. But it's likely my students might be better than me at this skill. So we have a rectangle LMNO, and we want to rotate it 180 degrees counterclockwise about the origin. And the origin is here in the center. So we're rotating from the center. Now, when we are doing this, my recommendation is always take a piece of paper and physically rotate the paper that many degrees. I cannot rotate the paper that many degrees, so in this video we'll have to do other strategies. So here's what I do. I look at the point that is closest to the point of rotation, which is point L right here. And I notice that point L diagonally is 2 diagonal units away from the center. So when I do 2 turns, that's 180 degrees, that's 1 turn, or counterclockwise would be this way. So this is 1 turn, and this is 2 turns. I have to be 2 diagonal units away from the center. So that puts my L shape at right here. Now, I always think of the shape when M is rotating this way and then rotating down again. Okay, that means that my M has to be all the way rotated down here below L. So if L is here and M is 1, 2, 3 units above it in the pre-image, it has to be 1, 2, 3 units below in the image. I'll put our little tick marks here. So we got L and we got M. So then N has to be opposite of L, and it's going to be 1, 2 units away from M. So there is our N prime. And then finally our O has to be 3 units away from N or 2 units away from L. So it's going to be right up here. So that's how I break down the strategy. I start with the closest unit, and then I kind of work my way around. Now, the ones that are probably easiest to see are the one that's closest and the one that's furthest away from the point of rotation. And then you have to be real careful to think about M rotates all the way around so that it ends up being below L prime. Whereas O rotates all the way around and has to be between L and N on the opposite side. So let's do another example here. So we're going to rotate triangle ABC 90 degrees clockwise about the origin. And almost always we're going to rotate about the origin. So in this case, origin is right here, and we're rotating 90 degrees. That's one turn clockwise. So that's this direction. So I'm rotating over here. So we look at our closest point, which is C, which is right here. And C is -3, 3. And once again, if I look, it is diagonally 3 units away from the center. So when it rotates clockwise 90 degrees, it has to once again be 3 diagonal units away from the center. So C prime is right here. Now B, for example, is going to rotate here and then down, so it's going to make it flat on the side down here to the right. So that means 1, 2, 3 away has to be my B prime. And now A has to be a diagonal line from C, and it has to be 1, 2, 3 units away from B. So it has to be diagonal, so like this, and 1, 2, 3 units away from C gives us our A prime. So here is our new triangle. And I always think triangles are pretty easy to make a mistake on because it is very easy to, especially for me, to visualize in my mind how that shape turns as I'm solving it. So it's really good to physically take out a piece of paper and physically rotate the paper as you solve these problems. So let's do one more. We're going to rotate that same triangle, ABC. This time we're going to do 90 degrees counterclockwise. So counterclockwise is going to be this direction. It's going to end up down here. Once again, though, C has to be 3 units away. So if it is originally -3, 3, that means our vertical and horizontal components have to be 3 units away from each of the axes. So in this case, it's going to be 1, 2, 3 diagonal units away, and we're going to call this C double prime, just so it's not the same as the original one. So now this is where it gets a little bit tougher to tell where everything goes. So this time A is going to rotate all the way down, which means B is going to be closer to the x-axis because B is going to rotate and stay up here. So 1, 2, 3 units away from C, 1, 2, 3, our B double prime has to be right there. Now A to C has to make a diagonal, so that means A has to be down here somewhere, and 1, 2, 3 units away from B, 1, 2, 3, so our A double prime is going to be down here 3 units away. So that is the first couple examples of rotations. Not my strongest topic. I work really hard to get better at these, but the best hint that I can give you is the thing that I do myself. I physically take a sheet of paper and I rotate it to help me see the visual picture of what I'm trying to draw. If you are willing to rotate the paper physically, rotations get better as you practice them. As always, if you have any questions, please let me know.